ladies and gentlemen. So here's the review for our test. I'm going to kind of go through and try to show you how to do a lot of it, but I might not necessarily do all of the different parts when checking things. So just so that you're aware of that. And a lot of this test is about being able to look at a graph, look at information, and use that to compare sets of data. So number one, the graph below shows the distance a cheetah ran. A giraffe can run at a rate of 0.25 miles. Which statement is true about their speeds? So I have to first figure out, well, how fast is the cheetah going? So I'm going to use this point right here, and that's 3/5. So I know the cheetah, when I divide that out, is running 0.6 miles per minute, and there is the giraffe. So now I'm going to go through my choices. The cheetah traveled 0.6 miles per minute. 0.6 miles per minute, choice A, done. For number two, which table represents a linear function? A linear function means you have to have a constant rate of change. So I'm going to just show you the one that actually worked. It was choice C, and we're going from -3 to 2 is 1, going up by 1 every time, going down by -2. So -2/1 is the same as -2/1 is the same as -2/1. So as long as when you do those and you simplify them down, you're going to get, if you get all the same things, it's going to be your constant rate of change. So linear functions have to have a constant rate of change. A plant is a certain height. The height of the plant is measured for several weeks. The graph shows the height of the plant for each week. Which statement is true? The plant grew 1 inch each week. Well, if you look here, to go up 1 inch, it actually took 1, 2, 3, 4 weeks. So that wasn't it. The plant grew 0.75 inches per week. Again, if you do 1 divided by 4, you're not going to get that. You're going to get 0.25. The initial height of the plant was 4. Well, that's at week 2. So it's not 4 there. Can't be. The initial height of the plant was 3.5 inches. So if you do that, if you actually take this and you were to extend the line, it would start at 3.5 inches, choice D. Here's another one, again with looking at our graph, being able to write an equation from the graph. So we're talking about how much food the rabbit eats. So in order to write my equation, I need to know what my rate of change is. This one happens to be proportional, because then I can also go and just look at my unit rate, which is right here. So the rabbit ate 60 pounds in 1 week, which would be choice B, 60x. Next page. The graph at the right shows Lena's total distance in miles for each day she's training. What is her distance on day 10? Well, I wrote my equation first, so I know she's going 3 miles on day 1, y equals 3x, and then I put in 10 days. Y equals 3 times 10, so 30 miles, which was choice C. Here's another, again, linear function. You have to have constant rate of change. And this one, again, I'm just going to show you the one that ended up working for it, which in this case was choice D. Here we're going up by 1 in my y. Here I'm going up by 2 in my x. So 2/1, 2/1. Sorry, 2/1. Number 7, I told you in class to cross off. There's actually no correct answer for that one. I don't know what happened there. Which of the following represents a nonlinear function? Nonlinear functions have exponents other than 1. So when I look, the only one that has an exponent other than 1 is A, nonlinear function. Next page, which graph does not represent a function of x? In graph form, we're looking for where if I draw a vertical line, I'm going to hit 2 dots, so choice C. And the 4 tables, so in table form, which one which table represents a relationship that is not a function? That means that we're going to have repeats in x. So when I look at table T, I have 2 3s there. So that's the one that's not a function. It's supposed to be an x, not a y. Okay, next, graph. Create a table of values. So I told you you needed to use -2, -1, 0, 1, 2. And when you fill those into your equation, you're going to get positive 2, 4, 2, and negative 4. Then I wanted you to graph it. So 1, 2, 3, 4. This one's kind of hard to read. I'm sorry. There we go. So it's our U-shaped. It's a curve because it has an exponent other than 1. Okay. Number 12, Mary Lou buys bagels for a number of office staff each day. Each bagel costs $1.75. Write a function to represent this situation. Y equals $1.75x. It's proportional. There's no b. Make a function table, which is really just another name for my table of values. This time, though, they're telling me to use 3, 5, 7, and 9. So this is 3 times $1.75. This is 5 times $1.75, and so on. You should get 525, 875, and again, this was all calculator work. 1225, 1575. They wanted you to graph it, so this is the number of people. Yes, people. This is the cost. I went by 1s on the bottom and I went by 2s on the side. So we had 3 and 525, so that's about there. We had 5 and 875, 7 and 1225, 9, 1575. Now, I cannot connect those. State the domain of the function. The domain are your x values, 3, 5, 7, 9. Range are your y values. So 525, 875, 1225, 1575. Is the function continuous or discrete? Explain. It's discrete because you can't have part of a person, which is why we can't connect them. Okay, number 13, a cube has a side length of s inches. The surface area of the cube is represented by the expression 6x squared. It's a function of its side length. Does this situation represent a linear or a nonlinear function? It is nonlinear. Explain. The exponent on s is a 2. That is why it's going to be that way. All right, last page. Ooh, we're getting through this kind of fast. Total cost of running a lawnmower from Lawns Incorporated is represented by the function y equals 10x plus 15. And the cost of running a lawn, this is Green's Lawns. And they want us to compare the function's rates of change. Well, in lawns, the 10 represents your rates of change. So for lawn, it's $10 per hour. For green, I have to figure it out from my chart, right? Constant rate of change. So we're going up by 1, and we're going up by, I believe, 9. So for green, it's $9 an hour. So the lawn is, you can say the lawn is more, you can say green is less, however you want. Find and interpret the initial value of running from green lawn. So I have to do my pattern backwards. Right? We've done this before. I'm going to just rewrite it over here. So if I start at 2 and I need to go backwards to 0, well, if I'm going up, every one I go up over here, I'm going up by 9, which means every 2 I'm going up, it's 18. So what plus 18 gave me 38? 20. So find and interpret the initial value. So that's your B, or y-intercept. So your B is 20, which means there's a flat fee of $20 charged. So no matter how many hours they work, they charge a flat rate of $20. Which company would you use if you want to rent the lawnmower for 6 hours? So I'm going to figure out for lawns first, using my equation, y equals 10x plus 15. And that'll give me, if I'm doing 6 hours, 10 times 6 plus 15 is going to give me 75. And for green, I know now my equation is y equals 9x plus 20. So 9 times 6 plus 20, move this up a little bit, sorry, is going to give me 74. So which company would you use? I would use green because it's $1 cheaper. And I know some of you are saying it's only $1, but it's still cheaper. Okay, for number 15, I don't know why those lines showed up on the paper. I don't know what I did wrong. So graph it. Again, I'm going to do my table of values. Same values we used before, -2, -1, 0, 1, 2. And you get 1, 4, 5, 4, 1. Again, I totally did those all on a calculator. So when I graph it, we're going to get that same type of U shape that looks like so. Okay? So if you can do the stuff on here, you should be able to do fine for the test tomorrow. Watch it as many times as you need to, add things to your index card, and that's really the way it goes. Any questions? Try and see me, I guess, tomorrow. Have a good night, guys.